Okay, so the next question, what are the bit masks used for? The short answer would be that we can use masks to set or clear specific bits in the input by applying a mask and the corresponding input operation, such as OR, exclusive or AND. So I would like to show you some examples of this. Let me first scroll all the way to the top and save my latest changes, and then I'll just jump and show you an example of a C programming language where we have this example of a bitwise operators and masks. So this is an example in C. So it just simply tells you what bitwise operators and masks are good for. To begin with, we use some bit input, which is binary 0, 1, 1 or decimal 3, and we'll treat it as a user input, and we'll set the mask to 0, 0, 1, which is a binary mask. So I'm just trying to show you potential scenarios here. We can say that first, because remember, when we are applying masks, one of the things that we have to be careful about is to watch out that both the input and the mask have to be the same size. So let's compute the bit length of the unsigned integer. So what we can do is that we can say, okay, what is the size of this unsigned integer data type? And size of operator returns the size in bytes. So on my system, I know I'm, for instance, running in 32-bit mode when I was first running this program, and so therefore the integer will be a 32-bit size, and the size will return 4, which means unsigned integer taking 4 bytes in memory. Now each byte includes 8 bits, so I'm multiplying it by 8. So this is sort of like a formula, the most formal approach to say how many bits does the unsigned int contain. Okay, so this simply should give me 32 on 32-bit platform. And in most of the cases, in standard environments using C and C++, unsigned int would continue to be 32-bit even on 64-bit platforms. So here's an example of taking this lowest bit that we just set in this 32-bit sized mask, and what we do is that we apply a bit shift operation right here, and we say that we have these 32 bits, so let's basically take these 32 bits. I'll give you a demonstration. So this is my integer in memory, and it contains 32 bits. The first bit is set to 1, the rest of the bits is set to 0. And what I would like to do, I would like to move this 1 to the highest bit. Okay, so I just computed the bit length, which is 32. I take bit length, which is 32 minus 1, it will be 31. And so this time I'm just saying that let me take this 1 and move it 31 positions over. So this binary bitwise operation, which looks like this, does exactly what it's implying by its notation. It's like directional move of bits inside this unsigned integer. So this bit will be moved to the leftmost position if I did everything correctly. And what happens to the original bit is that everything else by this bit shift operation is filled from the right hand side with zeros. So all of these values from the right hand side to here will be set to 0. And so therefore effectively my original bit is going to jump over to the signed bit position in my mask. So now my mask is set to 1 on the left hand side, and everything else is filled with 0. Now let's make some. Remember that the initial input is 0, 1, 1, and now I change my mask, so now this 1 jumped to the leftmost position in its 32-bit size. How do you clear bits specified by the mask? So what we do is that we change the mask. So remember, my mask is set to, my current mask is set to basically contain 1 and all zeros on the right hand side of it. But the tilde operator is an actual bitwise NOT operation. And so what this does, it changes each bit, so the leftmost bit will become 0 and all other bits will be set to 1. So this is the type of mask that I will have, with all 31 bits on the right set to 1 and the leftmost bit set to 0, because this is what I do. I use tilde operator to flip all bits in the original mask. And I use the AND operation, so obviously what this will do is that it will clear all bits specified by the mask, because the original mask right here said that I want to clear this bit, right? So my mask was set to 1 to indicate that this is the bit in the input that I want to change, or I actually want to set to 0. So you can see here, by doing this manipulation, I can achieve that, to specify in the mask which bit do I want to clear. And then I flip the bits and I apply the bitwise AND operation. This is C programming language bitwise AND operation, which is just a one single ampersand, and it will do the work. Of course, using a short arithmetic form of assignment essentially shortens this expression. How do you also set bits specified by the mask? So the next challenge is that, once again, let's go back to my mask. So my mask is 32-bit size. The highest bit is set to 1, as we demonstrated, and we just simply apply an OR operation. So every time, so these are all zeros, right? So these rightmost bits are all zeros, and we are using a bitwise OR operation by using the original bits. And so what this will do, it will say that whenever we're ORing with 0, the input will not change. But if we are ORing it with a 1, it will definitely be set to 1. So this is how you say, this is my mask with this specific bit set to 1, and now I want to use this mask to set this bit in a specific input, and this is the way to do it. There's also interesting question to say how to test if any of the bits are actually set. So we have an input, and the question is it all zeros, or are there any bits set? So of course, I mean, once again, we just can AND with the mask, and remember, this is not just testing for let me just give you a short example one more time. So say that this is my input, and some of the bits are set to 1 and some of the bits are set to 0, something like this. And then I have this mask, and I say that I want to check this bit and this bit and this bit to see if any of them are set. So my mask would look like this, with zeros and ones, and I say that only these specific bits I want to check, and I want to find out if any of them are non-zero. And this is the way to do it. You just basically say, if this yields some kind of non-zero result, then yes, some of the bits that were requested are set. Otherwise, no, none of them were set. And the final example here says how to test if all of the specified bits are set. So you're applying the same technique. You have the mask that indicates the specific bits, and you're ending it using the bitwise AND operator right here, ending it with your input, whatever your input is, and you get the result. And then you compare it with precisely the same mask, and you say, oh, if this really equals to the original mask, it means that all of the bits that were specified by the mask are set. And when we talk about bits, set means 1 and clear means 0. So that's a typical terminology as we use. Well, where exactly these types of masks would be useful? Well, perhaps first of all, there could be multiple situations. Of course, when you're controlling a hardware, if you're writing a device driver, of course, the hardware controller uses specific bits for inputs and specific bits to give you the status and other bits to accept certain commands from you. So you just simply take whatever bitwise fields the hardware controller has and start using masks to set specific bits, clear bits, and test whether they're set. So all of this technique is, of course, is just straightforward approach to manipulate individual bits. In addition to this, you could be using this same technique if you have captured a state. So instead of, for example, creating 32 different Boolean variables in your code, you can use one integer and treat individual bits as your flags, Boolean flags, true or false. And of course, if you want to treat them as individual bits, you would have to know how to apply these masks.